On this lesson, we're going to see what can we do with those least common denominators to solve equations with rational expressions. Rational expressions, big fancy way of saying some algebraic fractions. If we go back to the very beginning of the semester, we solved equations that had just fractions. And the way I taught it was, let's just get rid of those fractions. And how did I do that? Well, the way I did that is I taught you to find the LCD, and I asked you to multiply each term by the LCD to get rid of the fractions. Let's see if we can remember that. So between 2, 3, and 18, remember we're looking for that least common multiple. The smallest number that they all divide into is 18. So we multiplied this one by 18, this one by 18, and yes, that by 18. And then we reduced. 2 goes into 18 9 times, 3 goes into 18 6 times, 18 goes into 18 1 time. And then we simplified that, because now on the denominator we just have 1. So we have 45x minus 12x equals negative 11. So we collected like terms, and we solve for x. I know you can do this because we did this months ago, and y'all did a great job. We're going to be doing that same thing, except our denominator might have some variables. So when we're solving our equations with rational expressions or those fractions, we're going to do exactly what we did at the beginning of the semester. We're going to find that least common denominator. We're going to multiply every term by the least common denominator to get rid of those fractions. Then we're going to solve. But now we have to check, because some of those variables are in the denominator, we cannot divide by 0. So we got to do some checking here. Not to check if our work is correct, but to make sure that we're not dividing by 0. But let's go back to one that we've done before. We only have numbers in the denominator. What is the least common denominator between 3, 4, and 12? The least common multiple between 3, 4, and 12. I know, you know it's 12. And remember, we're going to put parentheses around that just to be careful. So I'm going to reduce. 3 goes into 12 4 times, 4 goes into 12 3 times, and 12 goes into 12 1 time. So once again, that wipes out our denominator, just has 1. We want to be careful here. I'm not going to distribute to the next step just to be safe, because I don't want to lose things like that. Now I'm going to distribute. I'm going to collect like terms. So we're going to have negative 8x and negative 25. We're going to add 25 to both sides. So let's see, I get negative 8x equals positive 36. If I divide by negative 8, I could reduce that. Let's see, they're both divisible by 4. So 4 goes into 36, 9, negative 9 over 2. Now how do I check? How do I check my answers to make sure I'm not dividing by 0? Well, let's erase some of this mess here so we can see. Are there any x's in my denominator? No. This denominator is always 3, that denominator is always 4, that denominator is always 12, so we could not possibly divide by 0. That's only a case when you have variables, like the next one. Okay, so if my x is 0, that would not be good. Alright, so I know x cannot equal to 0. But let's see even if it does. That's just, I can't divide by 0. But let's go through and how to solve number 2. What is the least common denominator? That least common denominator. Well, we got to look at 5 and 15. What's their least common multiple? Yes, 15. And then the only other factor is x, and remember we raise that to the highest power, and that's just to the first. So I'm now going to multiply this one times 15x, this one times 15x, and this one times 15x. And I'm going to reduce. The x's divide out. 5 goes into 15 3 times. Here the x divides out, And here the 15 divides out. So again, my denominator now is just 1. Let's be careful. I have a 3 times 3, which is 9. I have 15 times 1. And here, don't leave out that x. Collecting like terms and dividing by 2. That's it. So how do we check? Again, I'm going to just erase this. We're checking to make sure if I put in 12 for x, does it make my denominator 0? Well, of course not. 5 times 12 is 60, and that's 12. So I'm not dividing by 0, so that's an okay answer. If you don't believe me, pick up a calculator and try to divide by 0. It's going to tell you error. Remember, it's undefined. Let's look at these next two examples. So we need to find the LCD. Well, between 6 and 3, just 6, and then my only other factor is x. So I need to multiply this times 6x, this times 6x, and this times 6x. Then we're going to reduce. The x's cancel. Here the the 6's cancel there, the x's cancel here, and then 3 goes into 6 2 times. Now let's be careful. We have x times x. Here a minus 6 times 2. Let's not lose that minus sign. That 2, and that x. So we're going to multiply all that together. That's a little bit harder than the last one because it's quadratic. We have an x squared. So we've got to set it equal to 0. So I'm going to add 4x to both sides. I'm going to stick it in the middle just to make it in the right order, because then I have to factor. Pretty easy. What multiplies to get negative 12 but adds to get 4? Positive 6 and negative 2. Then we set each factor equal to 0 and solve for x. So this time I have two answers to check. So I'm checking here. So there's no x here. The only place is there. So if I plug in negative 6 for x, is that 0? No. If I plug in 2 for x right here, is that 0? No. Those are your two answers. Let's look at number 4. What is that least common denominator? Now remember, that's over 1. The only factor you have is x, and you want to raise it to the highest power. So do not combine the x and x squared. You have x, and then take it to the highest power. So that's your LCD. So we're going to multiply this by x squared, this by x squared, and this by x squared. So what happens here? Nothing cancels because I already have a 1 in the denominator. Here I'm going to divide out and just be left with x, and here x squares divide out. So I'm left with 1 times x squared. I left me an x and the 3, and here that's just negative 2. So again I have a quadratic. I'm going to add 2 to both sides, set it equal to 0. I'm going to factor. What multiplies to get 2 adds to get negative 3. Set them both equal to 0 and solve. Then I need to check, and again going back to the denominator, the only denominator I have are x and x squared. If I put in a 2 here or here, that does not make it 0. If I put a 1 here or here, that does not make it 0. Both of those check, just like both of those check.